Let's take a look at the idea of calculating arc length for a parametric curve. Now, for non-parametric curves, if y equals h of x, the arc length from x0 to x1 is given by s equals the integral from x0 to x1 of the square root of 1 plus the first derivative of our function, that entire quantity squared. Which is the same as saying it's the integral from x0 to x1 of the square root of 1 plus dy dx squared. And we're going to use this to convert this to the idea of what it must be for a parametric curve. So if I have a parametric curve where x is given as f of t and y is g of t, where t is between a and b, then the arc length can be written as, see, this is straight from the Cartesian coordinates, but I'm going to transform this into parametric. So this is going to be the same as the integral of the square root of 1 plus, well, dy dx is dy dt over dx dt squared dx. So now I'm just going to hit it with a little bit of algebra. This is equal to the integral square root of dx dt squared plus dy dt squared over dx dt squared. And all of this is under the radical dx. Well, I can pull out this dx dt squared in the bottom here in the denominator. I can pull that out of the radical, which is going to give me the integral of the square root dx dt squared plus dy dt squared times dt dx times dx. Well, obviously dx's are going to cancel, which is going to give me the integral square root of dx dt squared plus dy dt squared dt. So let's go ahead and take a look at this. And let's just do a quick example and see what we've got here. Find the arc length given x equals e to negative t cosine of t and y equals e to negative t sine t from t equals 0 to pi over 2. Now, one thing I should note here is when I converted this, the x0 and x1, this is actually now t0 to t1. All right, so first thing I need to do, I need to find dx and dy. Well, dx dt is equal to, so I'm going to have a negative e to the negative t cosine of t minus e to negative t sine t. That's dx dt. Dy dt is going to be negative e to negative t sine t plus e to negative t cosine t. So this arc length from 0 to pi over 2 of this particular function, s, is going to be equal to the integral from 0 to pi over 2 of the square root of negative e to negative t cosine of t minus e to the negative t sine t, this entire quantity squared, the dx dt squared, plus negative e to negative t sine t plus e to the negative t cosine of t, that quantity squared, because that's dy dt, dt. Okay, so now it's time to do a bunch of algebra. So this is equal to the integral from 0 to pi over 2 times the square root of, see if I square this, I'm going to get a e to the negative 2t cosine squared t plus 2 times e to the negative t times e to the negative t cosine t sine t plus e to the negative 2t sine squared t. That's this thing squared. Hopefully I got enough room to do the other one. I'm probably going to have to bring it down here. Let's see if I can fit it in. Plus, when I square this, I'm going to have e to the negative 2t sine squared t plus, minus 2 times e to the negative t, e to negative t, sine t, so I'm going to slip this in here, cosine t, plus, sorry, I ran out of room, I have to come down here. This is going to be e to the negative 2t cosine squared t. I need a square root of all of that, of course, then dt. Well, that equals the integral from 0 to pi over 2. Now notice this is addition, so I can just drop these parens and not have to worry about any sign changes. Let's see if we get lucky, which I'm sure we will, and if anything goes away. I have a 2 e to the t, e to the negative t, e to the negative t cosine t sine t. And here's a negative of that same thing. So that's going to go away. And I don't see anything else offhand that's going to cancel. So let's just write this out. So we've got, so I have the square root of e to the negative 2t cosine squared t plus e to the negative 2t sine squared t plus e to the negative 2t sine squared t plus e to the negative 2t cosine squared t dt. Well, that's kind of nice because if I factor out this e to the negative 2t from these guys right here, I'll have, well, I'll write it one more time here. The integral from 0 to pi over 2 square root, this is e to negative 2t times cosine squared t plus sine squared t. And then if I do the same thing here, factor out the e to the negative 2t, I have plus e to the negative 2t sine squared t plus cosine squared of t. Well, that's really nice because this is just 1 and this is just 1. So this is really equal to the integral from 0 to pi over 2 of 2 times, square root of 2 times e to the negative 2t dt. That's going to be much easier to deal with. So let's go on and write this again. I have the integral from 0 to pi over 2 of the square root of 2 times e to the negative, was that 2t? Yeah, negative 2t dt. Well, this is going to be equal to the integral from 0 to pi over 2. I'm going to pull that radical out. Matter of fact, I'm going to erase that equals. And I'm going to put it out here, root 2. See, this is e to negative, 2t raised to the 1/2 dt. Well, it's going to cancel out there. So this is really equal to root 2 times the integral from 0 to pi over 2 of e to the negative t dt, which equals a negative root 2 e to the negative t evaluated from 0 to pi over 2. which is, of course, a negative root 2. I'm going to pull that out, that constant out. And this is going to be e to the negative pi over 2 minus e, this is going to sound silly, but negative 0. It's just 0, I know. So this would actually be a negative root 2 times e to the negative pi over 2 minus 1. And I think that's probably how I would leave it. I could distribute and do a few other things with it, but I don't know why. There you go.